This lesson can be utilized if you missed class on Friday, February 7th and 2nd or 3rd block. First, we're going to go over the warm-up. The first problem says y equals 3x plus 1. The thing that we must remember from the previous units is that in order to graph, you need to have it into y equals mx plus b form, where m is your slope, your rise over run, and b is your y-intercept. B is very important because it's always where you start on the y-axis. So in number 1, our y-intercept is positive 1. So we're going to start at positive 1 on the y-axis. Our slope, m, is 3. Anytime we have a number, a whole number, we can write it over 1. Our rise over run is positive 3 over positive 1. So we go up 3 and over 1, and we continue to go up 3 and over 1, or we can go down 3 and over 1 to continue our line. So this is our line of 3x plus 1. Number 2, our y-intercept, our b, is negative 1. So we put a point on the y-axis at negative 1. Our slope m is negative 1 over 2. That means our rise is negative 1. We go down 1. Then our run is positive 2. So we go down 1 over 2, down 1 over 2, and continue to go down 1 and over 2. Or you can go up 1 and to the left 2 because that would continue your line. That gives us this graph right here for the line y equals negative 1/2 x minus 1. Number 3, our slope is up 1 over 4. Our y-intercept b is 2. That's where we start. We put a point on the y-axis at positive 2. Because b is positive 2. My rise over run is positive 1 and positive 4. That means I'm going to go up and to the right. I go up 1 and over to the right 4. Up 1 and over to the right 4. Or I can go down 1 and over to the left 4 because a negative divided by a negative is still a positive. So down 1 and over to the left 4. Down 1, over to the left, 4. And that is our line for y equals 1/4 x plus 2. And the last one, y equals negative 2x minus 3. Our y-intercept b is at negative 3. So we start on our graph at negative 3. Our slope m is negative 2, but anytime we have a whole number, we put it over 1. So we go down 2 over 1, down 2 over 1, down 2 over 1. Or, just like before, we can go up 2 to the left 1, because that would continue our line in the same direction, and a negative divided by a positive is a negative, and a positive divided by a negative is a negative. So either way, we're continuing with that pattern. And so this is the graph of the line y equals negative 2x minus 3. Today's lesson's on whether or not you can graph linear inequalities. Graphing linear inequalities consists of 4 steps. The first step is to graph the equation and used a dashed or solid line. We used a dashed line if we have less than or greater than, and we used a solid line if we have less than or equal to or greater than or equal to. This is kind of along the same lines of using an open circle or using a closed circle whenever we're doing number line inequalities. So an open circle is kind of like a dashed line. We don't include what's on the line, but we include everything else. We don't include what's in the circle, but we include everything else. And a solid line is kind of like a filled-in dot for our purposes. The second step is to put a plus above the line and a minus below the line. And then the third step is to shade in the correct inequality. So if you think it's a plus, what do you think you're going to shade for? Greater or less would be plus. Greater. Perfect. So plus goes with greater than or equal to, and minus goes with less than or equal to. So your dashed line goes with greater than or less than. Your solid line goes with less than or equal to or greater than or equal to. And then you shade on the plus if it's greater and on the minus if it's less. Now I also want to take note here that it's important to realize that this is not the only way to do it, or once you do it this way, you can always check yourself. And the way you check yourself is by testing a point. So you can always choose a point where you shaded. I'm not sure if shaded has 1 or 2 D's. That looked wrong to me. I think that looks better. You can always choose a point where you shaded, and if it satisfies the inequality, then you've done it correctly. So let's go ahead and practice what kind of line we draw for less than or greater than. What kind of line do we draw for less than or greater than? Josie? A dashed line. So if you have less than or greater than, you draw a dashed line. What about less than or equal to or greater than or equal to? Avery? A solid line. Yeah. So that's all it means by dashed or solid. Whenever you graph that line on the XY axis, on the coordinate plane, if it's less than or greater than, you used a dashed line. If it's less than or equal to or greater than or equal to, you use a solid line. Okay, so we want to sketch the graph of y is less than or equal to 1. Okay, we're going to use the same exact steps that we used in the warm-up. What is our b, our y-intercept? What constant am I having on the right side? 1. So I know that this is going to pass through 1. Okay, what's my slope? What am I multiplying by x? What am I multiplying by x on the right side? Is there an x there? No, so what's the only thing that I can multiply by x that would make it not be there? 0. So I have a 0 slope, which means I have what kind of line? Horizontal line. Yeah. So I have a horizontal line at y equals 1. Now, I just drew that line. Do I have to do a dashed or solid? Solid. Why solid? Because it's less than or equal to. If it was just less than, I would have to do dashed. But since it was less than or equal to, I could do solid. So we're done with step 1. Let's go ahead and move on to step 2. Step 2 is to put a plus above the line and a minus below the line. So I'm going to put a plus up here above the line. I can put it in either quadrant 1 or quadrant 2. And I'm going to put a minus below the line. Our inequality says less than or equal to. Less than tells us to shade with the plus or the minus. Less than goes with the minus. So I'm going to shade the area down here. You do not have to get the area completely free of spaces. Just shade it lightly is fine. You don't need to shade a hole into your paper. Go ahead and look at example 2. It wants us to sketch the graph of x is less than negative 2. So for this one, it is not in y equals mx plus b form. This one is one of the ones we have to remember how to graph. No matter what y is, what is x? Negative 2. So that means I'm going to have points all the way up and down when x equals negative 2. When y is 5, x is negative 2. When y is 0, x is negative 2. When y is negative 3, x is negative 2. No matter what y is, x is negative 2. Okay? Now, I always draw a solid line. I always forget. But you've got to make sure you look at that inequality. Do I need a solid line or a dashed line? Dash, why? It doesn't have its or equal to, so it just has less than, so we need a dash line. So if you forget, you can always take your eraser and erase dashes in it. Okay? So you can put it as dashed, even if you forget. So this line is vertical. How do I know what's above and what's below? How do I know what's above and what's below? X is negative 2. What's below negative 2? Negative 3, negative 10. All the things that are negative is below. So to the left is minus. What about above negative 2? What's above negative 2? Negative 1, 0, 12. So everything over here is above negative 2. Do I have less than or equal to, less than, greater than or equal to, or greater than? Less than, so that means I'm going to shade on the side with the minus. So everything that's shaded is true for this graph. Everything that's not shaded, everything on the right in the dashed line, is not true for this graph. Example 3. Sketch the graph of x plus y is greater than 3. So we have x plus y is greater than 3. We need to put this in y equals mx plus b form so we can graph it. In order to do that, I need to get y by itself. I'm going to subtract x from both sides. X minus x is 0. I'm left with y. My sign does not change because I did not multiply or divide by a negative number. Make sure you're writing this down, not playing on your calculator. I have 3 minus x or negative x plus 3. It's the same thing. So if you want to write it as 3 minus x, you can, but you've got to make sure you remember that your intercept is 3 and your slope is negative 1, or rise over run, negative 1 over 1. I put a point at my intercept at 3. My rise over 1 is negative 1, 1. I go down 1 over 1, down 1 over 1, down 1 over 1, and I can continue to do that to make my line. My sign is greater than. That means I'm going to have a dashed line. So the points that I've put on the paper or on the screen, those are points on the line, but everywhere that the line's dashed is also points on that line. So just because I didn't put a point at negative 1, 4 doesn't mean that that's not a point on that line. Okay. If I look at this line, I can see that above it, I'm going to put a plus. And below it, I'm going to put a minus. It's a lot easier whenever you have a line than whenever you have just a vertical line with x is equal to a number, or x is less than or equal to, greater than or equal to. I have greater than, so that means I'm going to shade where the plus is. So I shade this side of my graph. Just for clarification, I could have put the plus here. I could have put the plus here because I'm shading everywhere that is above that line. I could have put the minus here or the minus here. I am not shading anywhere below that line. If you're watching the video, make sure and pause it if you need to, or rewind it if you need to. That is fine. Let's go ahead and move on to example 4. This one's a little bit different. This one wants you to write the inequality that this graph would represent. So we're going to start from step 3. We're going to look and see which side is shaded. Okay? Is it shaded above or below? Above. It's shaded above. I'm going to put my plus here, my minus here. It's shaded above. So I know it's going to be either greater than or equal to. Is my line dashed or solid? Solid, so it's not just greater than, it's greater than or equal to. Okay. Then I'm going to look and see where my intercept is. Where does this line cross the y-axis? It crosses it at 2. That means b equals 2. I'm going to add 2 to whatever my slope m times b part of my equation is. Okay, y goes on the left. We know it's greater than or equal to because I shaded above and I have a solid line. Now I need to figure out what my rise over run is. It looks like I'm going up 1 and over 2. Up 1 over 2, up 1 over 2. So that means that my slope is up 1 over 2, which is 1/2. So y is greater than or equal to 1/2 x plus 2. So first, let's decide what we're talking about with this graph. If we have a vertical line, the right is above, the left is below. So if we think about this line, it's almost vertical. We're going to have a plus over here on this side and a minus over here on this side. We're shading in the minus, so we're dealing with less than. We have a solid line, so we're dealing with less than or equal to. We're always going to have y as the relationship. Our y-intercept is here at 9. So b equals 9. We know we're going to add 9 to whatever our slope is. Here it looks like we're going down 1, 2, 3 over 1, down 3 over 1. So if our slope is down 3 over 1, we can write it as negative 3 over 1, or that's just negative 3. So y is less than or equal to negative 3x plus 9. So now that we have done it with writing an equation, drawing the graph, we've done it with seeing the graph and writing the equation from the graph, let's go into learning how to do it on our calculator. So I'm just going to make up a few problems and we'll graph them on our calculator. Say we have y is less than or equal to 11x plus 2. Y is less than or equal to 11x plus 2. So I'm going to do a y equals. I'm going to put in 11x plus 2. Then I have to think about what less than or equal to means. Less than or equal to means a solid line. And it means I'm going to shade where what is, the plus or the minus. Less than means I'm going to shade where the minus is. Okay, so that means I'm going to shade below. So I'm going to go over here to the left of y equals. Right now, it just has a line. If I press enter once, it's going to give me a thick line. If I press enter again, it's going to give me shading above, shading where the positive is. If I press enter again, it's going to give me shading below, and that is what I want. Okay? So you have to press the enter highlighted to the left of y equals and get it to where you want it shaded. Okay? If I just press zoom 6, it's going to give me only part of the graph. Okay? It has it where it's crossing the y-axis at the y-intercept of 2. It has it crossing here because b equals 2. But our slope is 11. That means I go up 11 and over 1. So we can adjust our windows to where it looks a little prettier. So if we go to our window, and we can leave the x min and the x max at -10 and +10. Okay? I'm going to make the y scale be 5 so that I only have a tally mark every 5 spaces. Okay? So I'm going to make the x scale, I'm going to leave it as 1, but I'm going to let the y scale be 5. Then I'm going to let the y max be about 30. And I'm going to let the y min be -30 so that we can see more of that graph. We don't really need to see more x, but seeing more y would let that graph be a little better. I'm going to graph it and see what happens. Looks a little nicer. I can still see where it crosses the y-axis at 2 because b equals 2. And I'm going up 11 and over 1. I'm shading below the graph because it's less than or equal to. So let's try another one. Let's say we have y equals, or y is greater than 2x minus 6. So I'm going to go into my y equals. I'm going to put in there 2x minus 6 greater than. Does that mean I shade above or below? Above. So I'm going to go over to the left. And I'm going to click enter until I get above. I have to click it several times. There's my dashed line. My solid line is back. And then I have it to where it's shaded above. I'm going to go ahead and press zoom 6 so that it will give us our regular screen back. We can see on here where our intercept is at -6, or the point 0, -6 for our y-intercept. And then you have m as your slope is equal to 2, which means our rise over run is up 2 over 1. Now the only thing that your calculator does not do is it does not give you a dashed line when you are shading. Okay? Your calculator is most useful in checking your work, not doing your work for you. So if you graph it on your calculator and you see it this way and you forget to put a dashed line, that's not on your calculator, that is on you. So for example, if you're using the calculator on a test to help you, you see, okay, that's the way I do it, so you graph it on your own paper. You put your y-intercept at -6. You go up 2 over 1, up 2 over 1, up 2 over 1, and you continue to do that. But when you graph your line, you have to put it dashed in order to get full credit. It's greater than, so we shade above. So doing it on the calculator is not a shortcut as far as doing everything right, because there's some things that the calculator is limited about. You do not have homework tonight because it's the weekend. However, you do have some class time left. And in this class time, I want you to do page 363, 24 through 62. And EOE means every other even. So that means 24, skip 26, 28, skip 30, 32, skip 34, 36, and so on.